Okay, so this is problem 28 from Equilibrium Supplementary Questions. We're writing out the problem here. The question says, at equilibrium, we have an equilibrium mixture. You should underline that in the problem. All three gases was found to contain, so this is found to contain 0.20 molarity SO2 and 0.40 molarity .4 SCl2. And the question is simply asking us to find the concentration of the SOCl at equilibrium. Okay? So that's the basic question. Finish it off. So because we're given 2 out of the 3 concentrations at equilibrium, that's the really important thing, and because we're also given the Kc value, finding the concentration of the 3rd substance at equilibrium is going to be very easy. All we need to do, we don't even need that ice table we've been drawing, because the ice table talks about the initial, the change, and the equilibrium. We already know 2 things at equilibrium, and we just need the 3rd one. So what we're basically going to do here is what? Well, before we rearrange, we'll write down the Kc expression. So Kc equals what? The concentration of SOCl squared divided by the SO2 concentration times the SCl2, right? So products on top, the reactants on the bottom, the SOCl is being squared because it had a 2 as its coefficient in the balanced equation, and these guys are to the power of 1 because they had 1s as their coefficients. And if you look at this carefully, you realize we know the Kc value, and we know the 2 bottom concentrations, and the question's asking us for the top one. So all we're going to do is substitute stuff in, right? Or if you want, start by rearranging. The concentration of SOCl squared will equal Kc times the SO2 times the SCl2. You with me on that? Yeah. Just rearranging with some algebra. And now the SOCl concentration will equal the square root of all that stuff. So Kc times SO2 times SCl2. And again, we know the 3 things that are underneath the square root symbol, right? So let's write them in. Equals the square root. The equilibrium constant was 22.4. And the important thing is that these other 2 numbers were measured at equilibrium, so we can put them in here. So the concentration of SO2 was 0.2, and the concentration of SCl2 was 0.4. So pick up your calculator, evaluate that, and you've got the answer to the problem. So evaluating it, I get 1.34. And because it's a concentration, we put its units molarity. Okay? I suppose technically it should have been written as 1.3, only 2 digits, okay, because there were 2 digits in the concentrations.